Good morning, Algebra 2 students. Looks like you're doing a good job getting going on that quiz that's due tonight. Please make sure you keep going. I'm answering the questions that I had asked of me when you filled out those forms. So hopefully these will help and get you going. And also there was a question asked on the last assignment, the last lesson that was taught, section 6.4, part 2, and I'm going to get to that question as well. So just hang in there and hopefully this will help you out. First of all, a couple people actually had emailed me and also asked on the form about if it says all real roots and wait, I'm looking for two answers here. Well, let's just think about that for a minute. The square root of 81 can equal 9 because 9 times 9 is 81, but the other possibility is negative 9. So I think some of you are forgetting about the other possibility, so just watch out for that. Someone else asked about clarity for absolute values. So for example, when you take an even root and you're square rooting 81, you get 9. And then you take the exponent divided by the root, and I get x to the third power. Okay. Here's the thing, is this was taken to the sixth power, but we don't know if it was positive or negative. So technically, when it comes out, we have to make sure that it's the positive version, because there was, when this was taken to the sixth power, it turned it positive. So the only time you have to think about that would be if you have an even power, and then once you've evaluated it, you get an odd root. This one, for example, 4 divided by 2 gives you 2 that come out. But since x squared is already positive, you don't even have to think about this. This is a rare thing. I don't want anybody to get hung up on that or think, wow, I'm going to lose all the points if I don't get that little technicality. It's one little extra thing only when you've had an even power, and once you divide it out, you get an odd power as their answer. So there's that. Someone else asked for another example of a problem that's like number 14. So let's work through this for a minute. If you remember, you're looking for the conjugate of the denominator so that when you multiply it out, you're going to end up getting rid of the radical in the denominator. Somebody else had asked about rationalizing the denominator, so I think that I'm covering both of your questions with this. We also have to remember that these are technically grouped because our big fraction bar acts as a grouping symbol. So let's multiply these out. If we multiply the numerator, the first 3 times 7 is 21, plus 3 times the square root of 2, plus 7 times the square root of 5, plus the square root of 10. This one's not going to really simplify down too much, this numerator, but our denominator is going to simplify a lot. 7 times 7, 49. Remember, the great thing about conjugates is that when you multiply 7 times square root 2, negative 7 square root 2, those two drop out. So we're left with minus the square root of 4. Just these two multiplied together at the end. So nothing actually in this numerator can be put together, but you always need to look to see if there's anything that can get put together. Because this one can't go with this one because they're different. This one can't go with this one because they're different. But if they could be simplified, you would need to do that. I'm mostly thinking about this denominator here. 49 minus 2, 47. And the numerator kind of always look to see if you can simplify. And I'll tell you right now, the one that's on your quiz will simplify, but I think, if I'm understanding you correctly, that the issue is knowing what to do with this denominator. And your key is to finding the conjugate and then just multiplying that out. Okay. Someone had asked about number 19. Now, number 19 is a bonus, so you're not going to lose any points for it. And I do have the form set up that you have to put in some type of an answer. And if you don't know and you have no idea, because that one is a really tricky bonus, all you have to do is just write I don't know, and it's not going to count against you. But I did have it set up that you have to at least acknowledge the question, and it gives everybody an opportunity to try. It has something to do with a triangle. I'll give you this hint. Okay, and the triangle's there, and you've got values here and here and here. And so what you need to do is you need to take those three values, because you're looking for a perimeter. You need to take the whatever was here and add it to whatever was here and add it to whatever was here. The reason it gets tricky is because it's all of those common denominators that are kind of interesting to find. So that's why I chose to make that one a bonus. If you are really, 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 really amazingly good at it, you can figure it out. Just it's going to take you some time if you decide to go for it. But that one's a 5-point bonus. And then there was one other 5-point bonus on there, number 20, which is actually way easier than this. But this is your hint for number 19 as far as what to do. Someone else had put on the form, could you please go over dividing with rational exponents? I think this is what you are asking. If it is not, you could possibly email me later and I can give you a little insight on that. But dividing with rational exponents, here we've got like bases. So that would mean that you subtract the exponents. 3/5 minus 1/8. Just as a little bit of a review, if you need to take 3/5 minus 1/8, you need to have common denominators to do that. So 5 and 8, the common denominator would be 40 times 8 times 8. So we get 24 minus 5/40, which would give you 19/40. Very strange looking exponent here. You're not going to get anything quite this crazy, but this is the process. The key is subtracting exponents. And to put that in radical form, even though it looks really weird, it's not that difficult, because remember, this is our index. And then the other one is our exponent. Index, exponent, index, exponent. And you can write it like that. And the last thing that I have for you this morning is that question from the end of 6-4 asked for another example like the one that was at the end of the last problem. So we're going to take a look at this. This negative 1/4 as an exponent needs to apply to both of the things that are inside. So that means I need to do 16 to the negative 1/4. And I need to do x to the 24th, or x to the 24th to the negative 1/4 means you multiply those exponents. I'll say it that way. So multiply the exponents. This one, there is just a 1 here in the first place. That's why it just comes in. But when I take 24 times negative 1/4, you end up getting negative 6. So this would be x to the negative 6th power. How do we handle this? Well, this one turns into 1 over 16 to the 1/4 power because of the negative exponent. This one turns into 1 over x to the 6th power. This one is nearly done. This one, however, a little bit more steps, not too much. We still have 1 over. It's the 4th root of 16. And you're looking for what number times itself, times itself, times itself, so that you've got 4 of them, would end up giving you 16. And that answer would be 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 1 over 2 times 1 over x to the 6th power, which is 1 over 2x to the 6th power. So my dear that sits in the front row, I hope that that answered your question. And also, I am praying for all of you. I'm praying for your families. And I hope that this helped you all. And have a great and wonderful day.